Hello, math buddies! Today, we're going to learn about the difference between permutation and combination. I am Cherdons and welcome to Math TV. Let us proceed. Permutation, the number of arrangement of a set of objects in which the order is important. Combination, the number of ways of selecting from a set when the order is not important. To sum it up, for permutation, arrangement, order is important. It is denoted by permutation of n objects taken r at a time is equal to n factorial divided by quantity n minus r factorial. While in combination, we have selecting, order is not important, denoted by combination of n objects taken r at a time is equal to n factorial divided by quantity n minus r factorial times r factorial. For instance, A, B, and BA are two different permutations because order is important, but they are counted as one combination because order here is not important. Another one, let's consider the permutation of the letters A, B, C taken two at a time. The value of n is 3 and the value of r is 2. Our formula, permutation of n objects taken r at a time is equal to n factorial divided by quantity n minus r factorial. Plug in the value, permutation of 3 objects taken 2 at a time is equal to 3 factorial over quantity 3 minus 2 factorial. Simplifying it, we have 3 times 2 times 1 over 1 factorial. 3 times 2 times 1 is 6 divided by 1 factorial and that is 1. So 6 divided by 1 is equal to 6. Therefore, there are 6 ways. By listing method, we have AB, BA, AC, CA, BC, and CB. We have 6 ways. As you can see, AB and BA is different. Why? Because order is important. Now, let's take a look at combination of the same letters A, B, C taken two at a time. N is 3, R is 2. Our formula, combination of n objects taken r at a time is equal to n factorial over quantity n minus r factorial times r factorial. Plug in the value, combination of 3 objects taken two at a time is equal to 3 factorial all over quantity 3 minus 2 factorial times 2 factorial. Simplifying it, we have 3 times 2 factorial all over 1 factorial times 2 factorial. Cancel out 2 factorial. We left with 3 divided by 1 factorial. So 3 divided by 1 is equal to 3. Therefore, there are 3 ways. By listing method, we have AB, BA, AC, CA, BC, and CB. Bear in mind that order is not important. So, AB and BA is considered as one combination. The same goes to AC and CA and BC and CB. So, it will trim down to 3 ways. Note that there are keywords to identify a permutation and a combination questions or statements. For permutation, we have arrangements, ordered ways, unique, permutation. For combination, we have select, choose, pick, combination. Keep an eye for these keywords. These are useful indicators that clearly show us whether the question is a combination or a permutation. Now, let us determine the following situation if permutation or combination is involved. Number 1, choosing 3 representatives for mathematics club out of 30 students. Let's say we have Fe, Lulu, and Alvin. Changing the order doesn't create new group. Order is not important. It involves combination. It can be solved as combination of 30 objects taken 3 at a time. Number 2, in how many ways can 5 players for a basketball team be chosen from 12 players? The keyword used is chosen. So we have a combination question. Order is not important. It can be solved as combination of 12 objects taken 5 at a time. For number 3, in how many ways can 10 cars line up for a race? Since 10 cards will be lined up, changing the order will create another arrangement. So, order is important. It involves permutation. It can be solved as permutation of 10 objects taken 10 at a time. Number 4, listing your 5 favorite movies in order from 20 most popular films of 2021. The keyword used is very obvious, in order, so it involves permutation because order matters. It can be solved as permutation of 20 objects taken 5 at a time. Number 5, picking 3 balls from a box of 10 balls. You're just going to pick 3 balls. There's no order for as long as you have picked 3 balls. So it involves combination, in which order is not important. It can be solved as combination of 10 objects taken 3 at a time. Number 6, how many set of 6 cards each can be formed from a standard deck of cards? The keyword used is formed. Changing the order of 6 cards doesn't create a new group. Order is not important. The question involves combination. It can be solved as combination of 52 objects taken 6 at a time. Number 7, in how many ways can 7 students be seated in a row? The keyword used is in a row. So, changing the order in a row will create another arrangement. It involves permutation, in which order is important. It can be solved as permutation of 7 objects taken 7 at a time. Number 8. There are 20 artists in a party. They greeted and shake hands. How many shake hands were there? In this question, we don't have any keyword. Let us analyze the situation. Let's say Sharon Cuneta shake hands with Lorna Tolentino. Does it make any difference if Lorna Tolentino shake hands to Sharon Cuneta? No, it's just one handshake. So order doesn't matter when it comes to handshake problem. It involves combination because order is not important. It can be solved as combination of 20 objects because we have 20 artists. Taken two at a time because every handshake there are two people involved. Number 9. In how many ways can 6 books be arranged on a shelf? Arrange is our keyword here. Order is important, so we will use permutation. It can be solved as permutation of 6 objects taken 6 at a time. Number 10, determining top 10 students out of 100 students who took and passed the entrance exam for senior high school admission test. To determine the top 10 students, we will arrange them in order. So, order is important. It involves permutation. It can be solved as permutation of 100 objects taken 10 at a time. I hope you enjoy our discussion for today. See you again for our next lesson. Thank you. Have a nice day and God bless everyone.